There's no rule saying it's harder to move a half mass twice the velocity, equaling a full mass going one velocity. Creating the same momentum requires the same work. The same momentum can never require more work to create. So if you're going to create something that has identical momentums, one of them can't require more work to produce. I mean, that's a pretty simple argument.
So I think your assertion there, your simple argument, really does illustrate your basic and fundamental misunderstanding of what you're trying to, you're trying to break the laws of physics, because you're saying there's no rule that states it. Well, no, it's not really a rule. Nobody stated the rule. It's nature. It's what nature does. Nobody set a rule in stone. They tested things, they observed things, they formalised things, and it's just how nature works. So, no, nobody set a rule. But your simple argument here, while it's a simple argument, it's fundamentally flawed. And this is your main sticking point here. So just as an example here, just say we had a 4 mass, we drop it from one distance, just say that's 10 centimetres, and that will achieve 1 velocity. And then we pit that against a 1 mass going 4 velocity, which would be equal in momentum. And as you just said, it wouldn't require any more work for make that to happen. Well, yes, it does. Because if we had the 1 mass and we wanted that to go 4 velocity, we would have to raise that to a height of 16 times the distance. So that would be 160 centimetres you'd be dropping it from. It would only be going 4 velocity. So it'd be a 1 mass going 4 and a 4 mass going 1. But to get the same momentum, we've had to put a lot more energy into the system. And obviously, you would get more energy back out. You put more energy in, you get more energy out. It's that simple. While the momentums are the same, they are equal. To make the same momentum, we've had to put a lot more energy in to the 1 mass to go 4 velocity. It's a fact, while you're saying that this can't possibly be true, try it. So if I was to drop a one mass from 16 heights onto a spring going 4 velocity, and a 4 mass from 10 centimetres onto a spring going 1 velocity, you categorically state that they're the same momentum and therefore they will do the same amount of work on the spring. Clearly they won't. You've already seen a 1 mass dropped 4 distances and a 4 mass dropped 1 distance. They are equal in energy. They're not equal in momentum, but they are equal in energy. So in terms of energy, for this one, we'd have a 4 mass dropping 1 distance, gain 1 velocity. So half the mass would be 2 times the velocity squared, which would be 1. So we'd have an energy of 2. So when we drop that onto the spring, it's going to compress the spring some amount. Its energy is 2. In this one, we've got 16 distances, 160 centimetres, and the velocity would be 4. So half the mass would be 0.5, velocity squared would be 16, 0.5 times 16 would be 8. So we've got an energy of 2 and we've got an energy of 8. So this one would have 4 times the energy when dropped. Because you put 4 times, you put 4 times the energy in, so you'll get it back out. The momentums, yes, it'd be the same, but the energies are not. This is the main distinction you have. You keep saying momentum is energy, and it's not. To create these 2 identical momentums requires different amounts of energy for that to happen. And if you put more energy in, you get it back out. You can't destroy it. You can't create it. What you put in, you'll get back out. It's that simple. That's the simple argument, and that's the true one.